Hello student, in this video we see the type 1 problem. Problem is design minimized finite state machine over the input set A and B in which the number of A's and the number of B's are divisible by 3. Means the input set is the string of input A and B, and every string in which the number of A means the count of A is divisible by 3 and the count of B is also divisible by 3, then such type of string will be accepted by our finite state machine. Got it? So how to design such type of machine? What logic is behind such type of machine? So see here, first the number of A's and the number of B's are divisible by 3. So like the string like that, triple A, triple B, so in which the number of A is 3 and number of B is also 3. So that is a multiple of 3, means it is divisible by. So this string must be accept. If we write like the order of A and B is does not matter. Got it? Means like A, B, A, double B. So again just count the total number of A's. So 1, 2, 3 and total number of B's is 3. So it is also divisible by 3. So it is also accepted. Now if we write like the string is like that is a 6A, 3B, 3, or in any order like first B, double A, double B, 4A. Got it? So again the number of A's in this string is 6 and number of B is 3. So 6 is also divisible by 3 and 3 is also divisible by 3. So number of A and number of B both are divisible by 3. So this string is also accepted. In same, this string number of B is 3 and number of A are 6. So again number of A and B is divisible by 3 because the total number of A's and total number of B's are divisible by 3. So we just take individual count. Got it? Not all count. So just number of A is divisible by 3 and number of B is divisible by 3. So in that condition we said that string should be accept. So like if we write like this the string, so in this string the length of string is 6, total character is 6, but the number of A's, count of number of A is 4. So number of A we can write like this, number of A is equals to 4 and number of B is equals to 2. So neither A nor B both are not divisible by 3. Got it? So that's why this string is not accepted by the finite state machine. Got it? If one string is divisible by 3 but other one is not, like this, like this. In this string number of A is 3 and number of B is 2. So the number of A is 3 and the number of B is 2. So the count of this in this particular condition, the number of A is divisible by 3 but number of B is not divisible by 3. So in this particular condition we say that again this string is not accepted by our finite state machine. Got it? Because the number of A is divisible by 3 but number of B is not divisible by 3. But in our statement we say that both number of A and number of B are divisible by 3, then such type of string will be accepted. Now what is the logic? Got it? We just understand which type of string is accept and which type of string is not accept. Now how to construct the machine? How to construct such type of machine in which the number of A and number of B's both are divisible by 3. So just remember one point. Any decimal number, when we divide that decimal number by 3, then what is the remainder is generated by that particular number. Means when we divide any decimal number by 3, then what is the possibility of remainder? So if you divide any number by 3, then the remainder is after dividing any number by 3. Okay. What is the point? The reminder is after dividing any number by 3 is either 0, 1 or 2. So reminder set is 0, 1, 2. Got it? If we divide by 3, then the remainder is either 0 or 1 or 2. So there are three possible remainder when you divide any number. Means you just count the number of a, and that count, what is the count? Count is a decimal value. When you divide that decimal value by 3, then the possibility of remainder is either 0, 1 or got it. So there are three possibility of remainder. So either it is 0, 1 or 2. So if we divide the number of a by 3, so we just say that number of a mod 3. So what is the possibility of result? It is either 0, 1 or 2. Same when we find the remainder when we for the number of b's when we divide by 3. So number of b mod 3. So the result will be either 0 or 1 or 2. Okay, got it? Means when 0, if the number is multiple of 3, if it is divisible by 3, then the remainder is 0. If number generate the remainder 1, if number generate the remainder 2. So three possibility when we divide the number by 3. So in this particular condition, we just see here what is the way to construct the finite state machine. So just remember that the possibility of number of A's remainder is 0, 1, 2, and the possibility of number of B's remainder is 0, 1, 2. So just find the Cartesian product of these two sets. Got it? Just find the Cartesian product, cross product of these two sets. Means all the combination of the remainder that generate when we divide the number of A by 3 and with all the combination of the remainder that is generated when we divide by number of B's by 3. Got it? So the possibility is that when we perform this Cartesian, so the one is 0, 0, the second one is 0, 1, the third one is 0, 2, the next one is 1, 0. Got it? When this 0 is crossed with 0, 1, 2, then it is 0, 0, 0, 1, 0, 2. When this 1 is crossed with this 3, so that is 1, 0, 1, 1, 1, 2. And when this 2 is crossed with this 3, so that is 2, 0, 2, 1, and 2, 2. Got it? So there are total 9 possible cases. So what is this values? What is this value? The first digit show the remainder of the A's when divided by 3, and the second digit show the remainder of B when divided by 3. Got it? So number of A and number of B, when both are divisible by 3, then the state is 0, 0. When number of A is divisible by 3, means the remainder is 0, but the count of B remainder is 1, then the state is 0. Means we just find out that total number of state in our finite state machine is 9. Total number of state is 9. How many state? There are 9 state. Got it? So total number of state is 9. Now, how to construct such type of machine? How to design such type of machine? So just see here. So there are 9 states here that in this 9 state we said that the state this 0, 0, you can just represent it by that q0, that 0, 1, you can say that it is q1, you can say that it is q2, q3, and so on. You just rename that particular state. Got it? Or you can put as it is such type of states. There is not any issue in the naming. Got it? Now, how to construct this particular finite state machine? So just see here, total 9 state. Out of this, we see here that the 9th state is, first one is 0, 0. There are 9 states. We just construct the structure. Machine for the input is 0, and 1. Got it? That is the state and input. So we just see here that we just give the naming 1 0 is 3. You can say that is Q4, Q5, Q6, Q7, Q8, and Q9. Got it? That I think that is Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8. Got it? Okay. So that I think that is a repetition of the state. Got it? So we just write down that 102 times. So just remove this state. Got it? So just write down one more time. See here. Just see here. That is Q0. Just rename the state. Q1, that is Q2, Q3, Q4, Q5, Q6, Q7, Q8. Got it? So there are 9 states, 0 to 9. Q0 to Q9, there are total 9 states. Okay? So in that particular machine, Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8. That is 9. Okay. Each state for each reminder means 0 0 for 0 0, that is Q0, 0 1, 0 2, 1 0, 1 1, 1 2, 2 0, 2 1, and 2 2. So there are 9 possible states. Got it? Now, what is the transition when we apply 0 input on the state Q0 means on 0 0? So just remember one thing, when the number of A mod 3 is 0 and number of B mod 3 is 0, then this state, then this condition is accepting condition. The question is that the number of A and number of B both are divisible by 3. So if we divide the count of A and count of B and it generates remainder 0, we divide the count by 3 and it generates the remainder 0 0. That means it is a final state. It is a final state. Got it? This state is final state. We said that it is a final state. Got it? So we represent it by circle, or you can make a star. For the final state, either we make a star or we make a circle in the table, transition table. Got it? So Q0 is the final state, and is Q0 is initial state? Yes. What is the minimum string that is accepted by our language? What is the minimum string that is accepted by this particular language, this particular statement? So what is the minimum string which is divisible by 3, in which the number of A and number of B? So if the number of A and number of B both are 0, means if the string is null, null means the string of length 0. Got it? So we can represent null by lambda. So the string of length 0 is called null. So in this string, number of A and number of B both are 0. Number of, there is not any A, there is not any B, means the number of A and number of B are 0. That means this string is accepted by our finite state machine. Should accepted by our finite state machine, because the aim of our machine is that all the string in which the number of A's and number of B's are divisible by 3. So in this string, the number of A is 0 and number of B is also 0, and 0 is divisible by 3. Got it? 0 is divisible by 3. Definitely. 0 is always divisible by any number. So it is also divisible by 3. That means if the number of A and number of B are 0, means our string in which the number of A and number of B are 0 is always accepted by this machine. Got it? Means all the string that generate null is accepted by our machine. Means null is accepted by our automata. And to accept the null, we should make initial state as a final state. Got it? So our initial state is also Q0 and our final state is also Q0. Got it? So just remember, just designing, we parallel design the machine and transition table both. Got it? So total 9 states. So we just write down here, that is Q0, that is a final state, that is also initial state, Q1, Q2, right? That is Q3, got it? Q4, Q5, this is Q6, Q7, and Q8. Total 9 states are there. Initial state is a final state. Now, what is the transition of input Q0? What is the transition of input Q0? There are two inputs. What state we write here? So, just one thing, that the input is, sorry, our input, what is the number of A and B? Not 0, 1. Our input is A and B. Just remember, not our input is A and B, not 0. So it may be possible in the question the number of zeros and number of B's are divisible. So it is just the name of the input. Got it? So our input is AB, not 0. Got it? So number of A's and number of B. So just count the number of A and number of B when you apply the input on this machine. Means when we apply input A on state Q0, means you apply single A. Got it? The string is single A. So the number of A's in this particular string, our string is this. When we apply this string on the initial state Q0, when we apply the input A on Q0, then number of A's in this string is 1. So count of A is 1, number of A is 1 in this particular string, and number of B's, how many number of B's are there? So definitely there is not any B in this string, means number of B is 0. Got it? So when we count the number of A, then it is 1, and just divide 1 by 3, then the remainder is, just find 1 mod 3, the remainder is 1, and 0 mod 3, the remainder is 0. Means after apply the input A, the state will be 1 0. Means the what is the state? The state is a combination of remainder of A and B. A's remainder, first digit is A's remainder, and the second digit is B's remainder. Got it? So what is the output state on the input A is 1 0. Now what is the 1 0? 1 0 is Q3. Got it? 1 0 is Q3. Means this state is Q3 state. Means when we apply the input A on Q0 state, then it will go to the Q3 state. Got it? So when you apply Q0 A, that is the Q3. Now, if the string is B, means when we apply the input B on this state, if we apply B, then what is the transition? This input B is applied to the Q0 state. Got it? So number of A in this particular case, number of A is in this string, the number of A is 0. Number of A in this string is 0. And number of B in this string is 1. Got it? So when we divide this 0 and 1 by 3, so just remember one point. When the count of A and B is less than 3, then the remainder is exactly same as the count. Means when the count of A is 0, count of B is 1. So when you divide this 0 and 1 by 3, then the remainder as it is 0 and 1. Means when the count of A and count of B is less than 3, then remainder is as it is. Means the same remainder 0 and 1 is generated. So 0 1 is the state. So 0 1 is state. Which type of state? That is Q1. Means on the input B, we go to the state Q1. That is the Q1 state. Got it? Now, so there is two transition for the input A and B that is done in Q0 state. So we just write down here Q1. Now on the Q1 state, when we apply the input A. So to reach Q1 state, we should read B, and after this B, when we apply A on this state, If you apply A on this state, so what will happen? So just see here. The input B and A means the complete string is BA. What is the string? BA. When you apply the input A on the state Q1. Got it? It's Q1 A. So the just read out the string from initial state. So it is a BA. So in this string, number of A's, how many number of A in this string? Just check how many number of A's? Exactly one. How many number of B's? Exactly one. So number of A is one and number of B is one. So when you divide the number of A and number of B by 3, then the remainder is also 1. Means when we apply the input A on Q1 state, then it goes to the state whose remainder is 1. So which state whose remainder is 1? That is Q4. Means when you apply the input A on the state Q1, it goes to the Q4 state. That is input A. Got it? So B and A transition N to Q4 state because the string BA generate remainder 1 and the state of remainder is Q4. Now, when you apply the input B on this state Q1, got it? Q1, what is the transition of Q1 on input A? That is Q4. So just write down Q4 here. Now, what is the transition when we apply the input B on the state Q1? So when you apply the input B on a state Q1, so in this particular case, that the complete string from initial state, just read out from initial state. So B and B, the string is double B. That is the string. Got it? When you apply the input B on the state Q1, so the complete state from initial complete string from the initial state is double B. So just remember one point. Always remember one point. You whatever the state where you apply the input, you just count the complete string from the initial state, and from that string you just count how many number of A's and how many number of B's. According to that, you just find the remainder, and according to remainder, you decide on which state particular input should end. Got it? So same here, when we apply the input B on the Q1 state, the complete input is double B, that is BB. So in this string, number of A, how many number of A's in this string? That is 0. How many number of B's in this string? That is 2. So again, the count of A is 0 and count of B is 2. Both are less than 3. Means it generate as it is reminder, that is 0, 2. Means if we apply the input B, then it goes to those steps whose reminder is 0. So on which state it should go? That is Q2. The remainder of Q2 is 0. Got it? So the remainder of this is 0, 2. So it goes to the state Q2. Got it? Now, in same way, exactly in same way, now what happened? The input of A and B both are done on Q1 state B, that is Q2. In same way, just see here for the Q3 state, if we apply the input A, now what happened when you apply the input A? So the complete string from initial state, just read out that Q0 A, that is double A. The string is double A. So number of A's in this string is 2 and number of B's in this string is 0. So count of A is 2 and count of B is 0. Both are less than 3. Means it generates as it is the remainder 2, 0. Means when you apply the input A on Q3 state, the input is end on the state whose remainder is 2, 0. So which state his remainder is 2, 0 is Q6. So we just go to the Q6 state. That's it. Got it? Now, if we apply the input B on this state, then the string is AB. What is the string? When you apply the input B on Q3, then the complete string from initial state is AB. So this AB string contain number of 1. A is 1, number of B is also 1. So 1, 1, both are less than 3, means it generate as it is reminder 1, 1, means it end on those state whose reminder is 1, 1. So Q3 on input B goes to Q4. Got it? So in the state, we just solve first Q3 state. After that, we can solve Q4. There is not any issue. So on the input A, it goes to Q6. On input B, it goes to Q4. Now just see for Q2 state what happened for Q2 state. Just clean the screen. You can write down every point. Now when we apply the input A on Q2 state, when you apply the input A on Q2 state, so what happened? What is the complete string up to Q2? That from initial B, B, and you apply A. So the complete string is B, B, A. So in this string, number of A's is 1. You just write down the count of number of A first, and after then write down the count of number of B, because in this particular, so first remainder is count of A and second remainder is count of B. So number of A is 1 and number of B is 2. So when you divide the 1 by 3, then remainder is also 1, and when you divide 2 by 3, then remainder is also 2. Means this 1 2 is a remainder. When you apply input A, it goes to those state whose remainder is 1 2. So which state whose remainder is 1 2? That is Q5. So you apply A, it goes to the Q5 state. Got it? So it goes to the Q5 state. That is the happen. Now on input B, just see here. On input B, what happens? On input B, the complete string from initial state is B, B, and B. On when we apply the input Q B on Q2 state, then the complete string from initial state is triple B. Just read out the first B goes to Q1, second B goes to Q2, and third B is applied after this. Then the complete string is triple B. Now in this string, just see here, in this string there is not any A, means the total number of A is 0, number of A is 0, and number of B is 3. So number of A is 0. When you divide it by 3, then remainder is 0, and number of B is 3, and when you divide 3 by 3, then also remainder is 0. Got it? We just see remainder. So number of A is also divisible by 3 and number of B is also divisible by 3, because the string contain exactly triple B. So triple B means it is a multiple of 3, and there is not any A, means number of A is 0, that is also by default multiple of 3, means triple B should be accepted. So it generates the remainder 0 0, means it goes to the Q0 state. On the input B, we go to the Q0 state. Got it? So on input B, it goes to Q0, and input A, it goes to Q5 state. Got it? So it is Q5. In same manner, you can arrange all the inputs of all the state. Just read out the complete string from the initial state, and after that, count the number of A's, count the number of B's, divide that count by 3 and generate the remainder, and that remainder is your the next state. Got it? So just see, check for one more Q4. Just check for Q4. So they just see here. To reach on state Q4, there are two directions. You can read from this BA. You can read from this AB. So you can choose any one direction. There is not any problem. You can choose any one. Both are correct way. You can choose any direction. So just apply the input A. When you apply the input A on this particular, so what happened? When you apply the input A, if we apply input A, so the complete string is BA. If you read from this direction, it is a BA. If you read is ABA. So you can use any one. Just use this direction BAA. So the string BAA, from initial, this B goes to Q1, next A goes to Q4, and next A is the input of Q4. So BAA. So it is the input of Q4. Now, what is the remainder for this particular string? So number of A is 2 and number of B is 1. Got it? So 2 and 1 both are less than 3. So when you divide 2 by 3, the remainder is 2. When you divide 1 by 3, the remainder is 1. So as it is remainder generated, so 2 1. So when you apply the input A on Q4 state, it goes to those state whose remainder is 2 1. So which state is remainder is 2 1? That is Q7. So just the direction is correct. You just reach to Q7. Got it? So on the input A, you just reach to the Q7 state. Now on input B. So when you apply the input B on the Q4 state, it reached to the state Q5 or not. Just see here. You can use any direction. We just use this direction in this time. Just A, B, B. The string is A double B. When you apply the input A on Q0, it is goes to Q3. When you apply B, then it goes to Q4. When you apply B, then the complete string, the input of Q4 is B. The complete string is A, B, B. So number of A is 1, number of B is 2. So it goes to 1, 2. So remainder of Q5 is 1, 2 means it is the correct direction. That is goes to Q5 string. Exactly same way, you just adjust the input of Q5, you just adjust the input of Q6, Q7 and Q2. So what is the transition of Q5? So we have just done Q4 transition. So just write down on the table Q4 transition on input Q4, A input it goes to Q7 and on input B, Q4 goes to the Q5 state. Now on Q5, when you apply the input A, just see here. So complete string from initial, you can use any direction. There are various directions to reach Q5 state. Just use any direction. From Q0 to Q1, the input B, again B, A. So to reach on state Q5, the one string is BBA. And when you apply the input A on this string, so the complete string is double A double B. So number of A is 2, number of B is 2 means the this input and on that state whose remainder is 2. So it is a Q2, so it goes to the Q2 state. Got it? Now, when you apply input B on this, when you apply input B on this state, what happened in this case? When you apply input B, so what is the complete string? B, B, just read out the string from initial BBA and the string is BBA and we apply the input B in this time. Previously, we apply the input A and the remainder is 2, 2, we apply input B. So total number of A is 1 and the total number of B is 3. Got it? So the remainder when we divide 1 by 3 is 1 and the remainder when we divide 3 by 3 is 0. Means it goes to 1, 0 state. See here, the number of B is 3. Means the remainder of B should 0 and the number of A is 1. And the remainder of A is 1. So it goes to 1, 0. So on which state it should go? So the remainder of 1, 0 is of Q3. Means on the input B, it goes to Q3 state. So it goes to Q3. On the input B from Q5, it goes to the Q3 state. Got it? So that is the logic. So Q5E is Q8 and Q5B is Q3. That is this. Now just map the input of Q6, Q7 and Q. Now on the input A, on the state Q6, when you apply the input A, what happened? What happened on the input A? So just see here. From initial state, read out the complete string to reach on Q6. What is the string? A, that is double A. On double A, we reach to the Q6 and after we apply the input A, then the string is triple A. The number of A is 3 and number of B is 0. So number of A mod 3, the remainder is 0. Number of B mod 3, the remainder is 0. Means it goes to the AA state. So you just, the first sample logic for each and every state, first count the number of A's and count the number of B's, then divide that count by 3 and generate the remainder, and that remainder is your next state. Got it? So exactly in this case, triple A is accepting state. Definitely triple A should be accept. So triple A and on the final state. Now if you apply input B on this, so it will go to Q7. So you can check, cross check. You can cross check. So Q6 input A goes to Q0, input B goes to Q7. Now on that particular state Q7, just see here on the state Q7 when you apply the input A, just see here. There are various directions to reach to Q7. So you can choose any one, like from B, Q0, that is BAA. So BAA is the string by which you can reach to the Q7. So BAA, using this string, you reach the Q7, and when you apply the input A on this string, so it becomes B triple A. So how many number of A's in this string? That is 3. How many number of b's? 1. So 3 by 3 is 0 and 1 by 3 is 1. You just find out the remainder. So number of a is 3. So that is divisible by 3. That's why remainder is 0. Number of b is 1, whose remainder is directly 1. So it goes to 0, 1. What state is 0, 1? That is Q1. So you just go to the Q1 state on input A. Similarly, on input B, it goes to here. You can cross check. Now, for next and the last state Q8. So first write down the transition of Q7. On A, it goes to Q1. On B, it goes to Q8. Now Q8 on input A. So just read out the path to reach on Q8 from initial. So that we use this path. You can use any path. So just read out that A, B, B. Got it. So double A, double B is the string to reach to Q8 from initial. And when you apply the input A on this, so total number of A is 3, total number of B is 2. So again, number of A is divisible by 3, so remainder is 0. Number of B is 2, that is less than 3, so remainder is 2. So 0, 2 is the state on input Qa, that is A input. So what is the state for the remainder 0, that is Q2. So on A input it goes to Q2. Got it. And similarly you can check on B input it goes to Q6. So it is a complete transition diagram and transition table for the particular question. Got it. So what is the transition? Q0, Q8, A transition, that is Q2, input B on Q8 goes to Q6. That is a complete transition table and transition diagram. So I think it is clear to you. So in such type of question, you just apply the same logic. The divisibility may be varies, the divisibility may be changed. So just use same logic on the all particular questions, which based on the divisibility. Got it? Thank you.